Today's is a fourth class or fourth class of the weekly problem solving session of NPTEL HS24. That is a course titled as Energy, Resource, Economics and Environment. My name is Sandeep Yadav. I'm a Prime Minister's Research Fellow at Department of Energy Science and Engineering, IIT Bombay. I will be taking these live sessions every week and of Tuesday 7 to 9 p.m. with the same link. So today we will discuss the topics which are this. Today we will discuss the problem. We'll solve the problems on Machiavelli, peak oil, Hubbard model, introduction to the renewable energy sources like hydro, wind, solar, tidal, ocean thermal, geothermal, biomass, and various other renewable sources. So before that, just wanted to ask if any one of you having any problem in the previous assignments, so that we can still take the some problems, or otherwise we will start with a brief summary of the lecture videos. If anyone if you have any problem, you can unmute, or you can if you are having problem with the unmute, you can type in the chat box also. Okay, so let's continue. So let me briefly summarize the lecture videos in which whatever the sites that will be important for you in solving the questions, I will take that slides only, and the theories are already available in the NPTEL videos of the week. Let's
Sir,
start.
can you please solve the previous assignment numerical question? 3 questions.
Which one? Which assignment?
Assignment 3, sir. Assignment 3.
Assignment 3. I think the deadline is still. You have the submission deadline, yeah? Or it's
Already
gone.
crossed, sir. Deadline is crossed, sir.
Deadline is crossed.
Yes, sir. Mark is already shown, sir. So
Assignment 2, 1 and 2 I've solved in the previous class. Correct.
sir, deadline 3 is also crossed.
Okay. So just give me a minute. I will just.
Okay, sure, sir.
So I'll start with assignment 3 first, then we will move.
Okay, sir.
I hope you can see the screen.
Yes, sir.
So this was assignment 3. I hope you if you have any problem, you can. I'll just start with the question number 1. Okay. So first question is, which financial metrics represent the internal rate at which the net present value of the project becomes 0? So as you can see, the financial metrics that represent the internal rate of return, that net present value of a project becomes 0, is an internal rate of return. So its straightforward answer will be B. If anyone of you need some more explanation, we have already given the explanation in the detail. I hope nobody will have any doubt in this question. Let's move ahead. Question number 2. Which of the criteria or criterion should be satisfied by the project so that the company decides to reject the project? So as we have already solved this type of question in the previous class, we just there are some things that will be needed to verify that that project should be selected or rejected, and that will be like net simple payback period of that project should be the more than the life of that project. This is the basic requirement. Other than that, net present value of the project should be positive. No, if this is also negative, net present value is, means that what is the value of that project in the current time. So if it will be negative, there will be chances that that can be positive in the near future. So that will not be a criteria to select or reject the project. Third thing is the benefit to cost ratio should be all less than one. That's a very basic condition. If we are having benefit to cost ratio more than one, then our projects will always be in the losses. So that thing we don't want it. That's why it should also be considered in the basic criteria. And the final thing is internal rate of return should be less than the hurdle rate. If we are considering like a hurdle rate is like a inflation rate or some rate at which we are getting the loans or so it should be less than always the internal rate of return, because if we are not getting the money that we are invested and otherwise we are putting more and more money in the project, then we will always end up in the losses. In that way, the option A, C, and D will be the uh, right answers. If you have any doubts, I can still clear. Otherwise, we'll move ahead. I don't see any comments in the comment section also. So I'll move.
Sir, it's okay. You can proceed.
Okay. Question number three is, what is the capital recovery factor used in the project? So it is asking what is the CRF that we usually calculate. CRF is to calculate the payback period. No, payback period does not have any relation in the uh, CRF. As you can see, CRF is just a relation of discount rate and the life of the project. So to determine the internal rate of return, no, to estimate the annual debt services to, so that will be the right answer. The explanation for this will, the CRF represent the annual payment needed to recover the capital over the project's life. So considering that the time value of money, this factor can be used to calculate the annual debt services, which include both the means CRF is the amount of money that we will receive annually based on the it's as a name says, capital recovery factor, by which factor we will recover our invested money. So that's why it will be used to estimate the annual debt services. Okay, let's move to question number 4. That's in numerical. A house owner replaces the conventional air conditioner with an inverter based air conditioner. So whose capital cost is 30,000 rupees. Due to some system, consumer saves 3 units of grid electricity daily, which average gets electricity price is 5 rupees per unit. Calculate the simple payback period in the years for the inverter based. So it's just asking to calculate simple payback period. So we know that there is a capital cost given. So initial investment for the plant will be 30,000 because we are just replacing a new AC with a old air conditioner. Second thing will be annual electricity savings. So we know we are saving 3 units of the grid electricity daily. So how many electricity units we will save in the year? That will be 3 into 365. So that will be around 1095 units we will save annually. Plus annual savings will be, we know the grid electricity price is 5 rupees per unit. So we have to, if you multiply this with the number of units saved, that will give us the amount of monetary benefit. That means how much money we will save annually by saving this much of unit electricity. So now we know annual savings, initial investment for the plant. So if you will divide the calculate the simple payback period, like invest that's equal to the initial investment divided by the annual savings. So that will comes around 5.47. That can be rounded off as a 5.5 years also. So that will be the right answer. If anyone you have any problem in this question. Okay.
I got it, sir. Sir, actually, I missed last video. That's why it is simple, sir.
So these
Thank you, sir.
last videos are already available on the YouTube. You can just revisit the videos.
Okay, sir. Okay, sir. Thank you, sir.
There's a session that is already available on the YouTube. If you'll go through that session, let me just show it to you. If you have any problem facing that, problem solving sessions. So suppose going into sure, this is the our NPTEL portal. So when you
Yeah.
see that there's a week wise content available on the left side, you will
Yes.
find the last column that is called the problem solving session. If you will go through this session, there will be problem solving session recordings. When you click it, there's a this tab opens problem solving session recording. Click here. You have to just tap on that link that will open an Excel sheet. And here you can see the
Okay.
YouTube links of each week. And there's a presentation folder also, whatever the things I'm teaching or whatever the material I'm using, that is going into this folder.
Okay, sir.
So you can just tap into this video. This will open in the YouTube directly. So you can just okay.
Okay. Thank you, sir.
Okay. So let's move into problem solving. So we are just doing yeah. So question number, let's move into question number 5. The company invests around 2 lakh rupees in a project with a life of 10 years and a discount rate of 8%. Calculate the capital recovery factor of the project. So it's a very simple formula. We already know CRF is D1 plus D to the power n divided by 1 plus D to the power n minus 1. This is a standard formula to calculate the. We already know the n value, that's a project life is given 10 years, and we don't know the discount rate. So discount rate is already given 8%. So now we have to calculate the CRF. CRF, we can directly put the values in this formula and you'll get it. So here's the if you want to solve this, if you solve this equation, you will get around 0.0857. So there's a one unnecessary information that is given is company's investment are. So this will not be useful to solve this question. Only you can calculate from the life and the discount rate. CRF is just a function of life and the discount rate. After a very easy question, we have just solved it many times in the previous week. Let's move into the problem number 6. Which of the following is a component of a life cycle cost? Life cycle cost. So as we know, life cycle cost encompasses all the costs associated with the project or asset to the entire life. So what will be the part of it? Initial investment? Yes, it will be the part of all life cycle cost. Operating cost, maintenance cost. So as we can see, these all options are fitting. So the correct option will be the option D. I hope this solves your problem. Let's move into the question number 7. Real discount rate is less than the nominal discount rate. This is a statement. This question about true and false. So this question is like this is true statement. Explanation is the real discount rate is typically less than the nominal discount rate. The normal discount rate is started with the interest rate without adjusting the inflation. So if we will adjust the inflation, that real discount rate will always be lower than the nominal because we have 5 to 6% inflation rate we have to consider. That's why real rate will be always be the less than the nominal discount rate. Let's move to question number 8. This is also true and false. Cost of energy saved decreases with the increase in the discount rate. Statement true as false? Yes, it is true. No, sorry, it's false. Why? The cost of saved energy is directly proportional to the discount rate. So when the discount rate decreases, the CAC typically increase with the increase in the discount rate. So here is saying it will increase, so it will just decrease. So that's why this statement is false. It's just giving a wrong statement. Finally, move to the question number 9. It's also a numerical. A factory installed a new insulation in their air duct with the insulation whose capital cost is around 5 lakh rupees. Due to this, factory saves 850 units of grid electricity monthly, where the average grid electricity price is 5 rupees. So just similarly, we have solved this type of question in the question number 3. This one. So in which it's asking not SPP, it's asking just some more information. It's asking if the life of the insulation is 10 years and the discounted years, find the net present value. So here we don't have to calculate the SPP, but the solution will begin with the same. So initial cost we know that's around 5 lakh rupees. Here it is given. Annual monetary saving we can similarly calculate. If we can save 5 rupees, no, sorry, 850 units monthly, then in the year there's 12 months. So there will be 5 into 12 into 850. So monetary savings will be 51,000 rupees. So life of the installation is 10 years and the discount rate is given 8%. So from that we can calculate the CRF. So CRF comes out to be 0.085. It's the same formula that we have used in the question number 4. This formula you can use, and this same thing here it is given 10%, 8%. That will comes out to be 0.085. When we calculate the CRF, we already know what is the NPV. Net present value is the A divided by CRF minus initial investment. So annual savings we have just calculated 51,000 rupees, and CRF we know 0.085, and we can subtract the initial investment. That comes out to be, so the final NPV will be 1 lakh rupees. So I have also received this doubt in the comment section also on the NPTL. So if anyone having any problem, we can still discuss how it's coming. Otherwise, we will move to the last question. Okay, I don't see any comments also, so let's move.
Got it, sir.
So question number 10, what is the signification of the negative value in the marginal abatement cost? That's also called the, so higher cost of electricity? No. It will be economical efficient opportunities for the emission reduction. So explanation for this will be a negative value of MSC will be curve signifies the economically inefficient opportunities for the emission reduction. Unlike the typical expectation of the positive MAC, a new value implies that reducing emission is not the only environmental benefit but also been economically advantageous. In this situation, business can achieve emissions reductions at a no additional cost or even the realize the cost savings, making this option as a environmentally friendly practice and a financially attractive. That's why marginal abatement cost will be having a significance in the economically efficient opportunities for emission reduction. So that's why option B will be the correct. I hope we have just solved the quiz number 3. If you have any problem, you can just revisit this recorded videos will be available on the YouTube. Otherwise, we will just move ahead. So let's move ahead with the this week's content. So I will just first briefly summarize the content covered in the slides. Let's start. So this is the, I will not cover the theory parts. I will just cover the whatever that will be helpful in the numericals. If you want more explanation, you can just revisit your NPTEL videos that will be explained by the sir. So this is the Machiavellic diagram. This shows the increasing degree of geographic assurance upon the versus economical feasibility of the resources. So the resources are measured basically in the demonstrated, indicated, in the inferred. So demonstrated we call also called the proven reserve. So if you will see here, proven reserves are the content that's already proven and measured. Other than that, there are resources that are available indicated. So indicated means they're having some probability that we will have this much of resource in the future. We can just inferred will be calculated on some theoretical values. So these are this Machiavelli curve shows the principle of resource classification. It's the same diagram. So to estimate the times, like how much time will be our resources will be available to that for our users, there are some methods that has been explained, like static R by P ratio. R here is the reserve and P stands for the production rate. Like if there are like 60,000 tons, million tons of coals available, and there's a production rate of 6,000 coal tons of coal per annum. So we can calculate it will around 100. It will take around some R by P time. That will be a time. So in this much time that resource will last. Other method is the exponential growth and the logistic growth curve and the Edelman's model. So the resources are typically defined. They're identified accumulation that can be extracted profitably under the present economic conditions. What are the resources? Resources are reserves. That means reserves plus all the accumulation that maybe eventually may become available, yet undiscovered, discovered, but currently not technically or economically viable. So this is a diagram shows the exponential increase in the annual uh, production of like coal production in India throughout the from year 1980, 1870 to 2010. It shows the exponential growth. So it is an example of our first method, exponential. It's second method, that's exponential growth. This So these are some theoretical values that these are given in the reserve. So suppose we have a Indian fossil fuels of we have 34,000 million tons of reserves available, and we have production capacity of 414 million tons per year for the year 2003 to 4. So R by P ratio will be 83. That means if we are continue with using this much amount of producing this much amount of coal every year, that coal will last around 83 years. So R by P ratios typically shows the years. So similarly, these things are calculated for the oil, natural gas, and uranium. So if you want more details, you can revisit the videos and further go through these references. So there are some examples that has been solved for the closed in the open market. So if you know the economies of the scale allows the falling when we found some resources initially due to the competition uh, due to the there will be fall in the price, and when there will be depletion in this resources, prices will fall, prices will increase. So this shows the price versus time graph, and same production will be initially start with a zero and attains a peak, and then will start decreasing with the time. Yes, similar thing will happens in the open market, but the thing is when the open market then we will substitute that energy source with some other sources, so that's why the price will also always decreasing, but the production rate versus time will also follows a bell-shaped curve. This is the data taken from the MK Hubbard model, which shows the world production of the coal. Similar other graphs are already explained in the video, so I will not go through that. Let's move ahead. So this is all the theory parts already covered. So this is the logistic model where the QP is the uh, production rate, and this is the amount of that we'll solve this type of numericals, then you will get some more clarity how this derivations solves a problem, because this derivation is already explained by the sir also. So I will just solve the question to give you some more clarity. This is the formula of the Hubbard model. Similar things, we'll go through this. This is all the theory parts. Let's move ahead. So other part of this lecture, the energy resources. So energy resources are primarily divided into the four key indicators, like primary energy sources, in which primary energy sources, this is and then the lecture one we have studied. There are some primary energy resources like nuclear fuels, fossil fuels, bioenergy, geothermal, direct solar energy, wind energy, hydro energy, and the ocean energy. If we see the energy carriers, so energy carriers are like liquid fuel that can be part of fossil fuel or solid fuel, can be part of bioenergy of or fossil fuels, gaseous fuels that can be part of direct solar energy also, and the electricity. Electricity, the major energy carrier. We can always convert this any form of this energy into the electricity. That's why it's from to electricity act as a major energy carrier here. We can also convert this liquid, solid or gaseous fuels into the with some conversion processes like thermal conversion or the kinetic conversion, and we can convert this energy, primary energy into the heat or work, and we can just convert that energy into the usable energy flow that can be heat and work, and we can finally take the end use that will be energy as a service, the heat based energy system, direct heating or electrical energy. We can always use the primary energy into a direct as an energy service will like a direct solar energy, in which we will not need any energy carrier or conversion processes also. I hope this graphs is clear. So this is just as a share of renewable in the final global energy use. Well, just things are already covered. This is the Sankey diagram. This is old data like 2000 global energy flows. So it shows the primary energy supply by the different energy primary energies like hydro, wind, solar PV, CSP, storage, and the combustion biomass. It shows that how much electricity we are generating from it, and what is the total energy flow, and how much it is going for the like out of 100%, 4.6 is going into the losses. Major consumption is by the other sectors like residential, commercial, public service, or some other sectors. And other than that, industry consumes around 13.5% of that global energy. This is a Sankey diagram that usually shows the energy flows for the different like uh, types of energies when into the if end consumer uses. Oh, now let's see what is the left side. This is a wind energy. How to calculate the wind energy? That's a formula that's explained. 1/2 rho v to the power 3. So it's there's a derivation. We will solve some numericals on that so that you can get some more clarity. Other than that, that's all other. There's a solar energy. So there's some factors that you just need to consider. There is a extra t- terrestrial radiation that can be that cannot be more than that 136 watt per meter square. So there can be some questions in the quizzes in the final exam also, like in which you can be asked what is the maximum limit of the solar radiations. So that will be around 136 one. Let's move ahead. This is all the graphs that are already explained by the sir in the videos. So I'll not go through this. This is the biomass conversion routes. If you will go through this, like there, biomass can be biomass cannot be directly used. It can be used, but for the getting some more efficient methods, we can convert that biomass to the some more efficient processes. Like there can be two type of two or three type of conversion processes, like thermochemical conversions. Thermochemical conversion includes combustion, gasification, and the pyrolysis. Combustion includes the Rankine cycle or Breton cycle, or gasification includes the producer gas which can be used with the atmospheric or pressurized form. Similarly, biochemical processes involve digestion and the fermentation. Digestion will convert the biomass into the biogas, and the fermentation will convert the uh, biomass to the ethanol, and some the biomass to the direct oil extraction. So this is some biomass conversion routes from the this is the same graph showing some more details. So I hope this week's content is fine. We will move to the problem solving session. If you have any problem, you can still ask. Otherwise, we'll just move. You can unmute yourself and talk. If you have any problem, you can write in the chat box.
Sir,
Yeah.
in one slide you have shown that extraterrestrial radiation is about 1361 watt per meter square. So what is
Yes.
extraterrestrial means?
Extraterrestrial radiation means whatever be the amount of solar light is going coming from the sun to the earth surface, that can be a maximum value per meter square. So that cannot be like sun's radiation energy is constant. So that the maximum value of that per square meter area is 1361.
Okay,
Okay,
sir.
got it. Okay, so let's move ahead. Just a minute. Yeah. Yeah, you can see my screen. Correct. Thanks. So let's start with the question number 1. Which of the following is correctly matched set when it comes to the natural resource classification? So let's see. And even if you want to answer, you can just type in the chat box or unmute yourself. So let's see with them from the option
Oh,
number 1.
hello, sir. The option would be fourth,
Yeah,
D.
D. Okay. Let's see. You are marking as the one option is the option number D. Anyone else? Okay. So let's move. So first thing is the coal or stock. So you can solve this question from the only from the one option itself. So let's see, like coal will be stocked. No, coal will be mined. So mining is done from where? So like if you have to mine aluminium, you have to mine some from the, there will be some aluminum ores. If you have to mine some coal, coal will be uh, mined in the from the ores. So first thing will the coal will be mined from the ores. So the correct match will be the ores. So if you see the option for the ores for the stocks, it will the E. Let's see other option. Wind will be stocked. Wind will flow. We can't stop. Can we stop the wind? No. So wind will always flow. So this is the option is the option number C and D and E. Since similar thing, the solar radiation will also flow. We can't store. Biomass will stock. So the correct option will be option number E. If anyone is having any doubt, so option number D is very close. If you can see, the only uh, one other matches are similar, only one match is different. If you don't have any problems, I'm just moving ahead. With respect to the probability of occurrence of resource, arrange the following from highest to lowest probability. I just taught this in the class today. You can answer. If you will participate, that lecture will
The
be more
first one.
interesting.
Sir, it's first one.
First, anyone else? I see there are 3 to 4 people in the chat box. You can still type. Or so there are typically 3 type of resources. One is proven, second is indicated, third is inferred. So if we see the probability will be moved from the upper to the lower. Proven resources are typically calculated, so that will have the more probability. indicated will be having some less probability, and the inferred will having the least probability. So the correct option will be proven, indicated. Proven will be the highest, indicated will be the median, inferred will be the lowest. The correct option will be A. Okay, let's move ahead. Resources are known occurrences and more economic to extract than the reserves. Is it true or false? I've just given a definition on the what is the resource and what is the reserves. Anyone want to answer? So here there are two things. One is resources, other is the reserves. So resources are, so if you want to know reserves are typically proven reserves. So if you want to know proven reserves will be less, but they are more easy to extract and they are more economical to extract. Reserves are identified accumulations that can be extracted economically. And what are the resources? Resources are reserves plus indicated and accumulated stuffs. So there are mostly uh, but there are the possibility of the reserves, but economically unviable right now. So the statement says that the resources are known occurrences and more economic to extract. No, that statement will be the false. Anyone having any problem?
No, sir, got it.
Okay, thanks. Let's move to question number 4. Which of the following sums up the Edelman's critique? So you have just seen this Edelman's model from the YouTube NPTEL videos. What do you think? What sums up? Let's see what the option by option. The total amount of resource available in the earth is fixed and can be estimated by the R by P ratio. Second is the resources will reach a peak at a point in time and then production will be ended due to the financial non-viability. Option number C, the total amount of mineral in the earth is non-binding constraint. If cost exceeded the revenue, whatever the resource remain will be unimportant. Yes, that's what Edelman critique is all about. Option number D, let's see also the total amount of resources is a binding constraint. No, that's a wrong statement. Correct, it's a non-binding constraint. And the production follows the, so let's continue. Correct option will be the option number C. This is theory question I've already explained. I don't think anybody will have any problem. Let's move to the question number 5. MK Hubbard estimated that the overall production trend of any resource will follow the following type of curve. Have you seen this type of curve? Yes, there's a type. So what do you think? How this curve looks like? Is this an exponential curve? So if you see the exponential curve, this will look like this. This is the exponential curve.
Sir, it will be
Linear
S-shaped.
growth, linear. This will be the linear growth, and S-shaped curve will be the around. First, it decreases, then it increases. So MK Hubbard model, as we have seen in the class, it's called a bell-shaped curve. This, as you can see, this is a bell shape. Whatever you're saying the S-shaped curve, that's a different model. Okay, let's move to the question number 6. The tidal range is difference between peak tide and the average tide, difference between the high tide and the low tide, difference in potential energy between the sea level and the lowest point in the ocean,
Sir,
or
second
cleanliness
one.
score of the coastline.
Second one, difference
Yes,
between high tide and
it's
low
a
tide.
it's a very easy question. Different between the high tide and the low tide. Very good. You're right. Let's move to the question number 7. Which of the following are biochemical extraction method of the biomass? I've just explained in the 10-15 minutes ago. Which of the following are the biochemical extraction methods?
Bio. Sir, C and D.
Pyrolysis? No, pyrolysis was a thermochemical process. So that will not be a part of a biomed. Gasification, it's also thermochemical. Fermentation and the digestion. These are two the correct options. Right answer will be the, so you have to, this is a multiple choice question. So you can select more than one option also. So the correct option will be the C and D. So let's move to the question number 8. Despite high solar radiation, India does not have enough space to meet all its present electricity demand of around 5 billion kilowatt hour through solar installation. Is it true or false? So let's see this with example. So we need 500 billion kilowatt hour of, okay, Shida, correct option will be false. Yeah, this statement, your answer is right. The statement is false. Let's see how. So we need for the 5 billion units, we need around 2,500 square kilometers of area. That will be around 50 into 50, or 4 smaller 25 into 25 square kilometer. Uh, this is also explained by the sir in the one of the slides also. So India is not totally reliable on the solar energy. So that statement is false. So we are not having enough solar capacity to fulfill our 500 billion kilowatt hour of unit requirement. Let's move to the question number 9. Which of the following statement is incorrect? So right. So which of the following statements are incorrect? All accumulation classified as reserves can be extracted profitably under economic conditions. Is it true? Yes. All, let's say second option, all classified accumulation classified as a resource can be extracted profitably under the economic conditions. No, all the reserves are economically extracted profitably under the economic condition, but all the resources are not. So that statement will be the false. And all the accumulation classified as the reserves are also the resources, correct? If we see thing, so this is the thing called, let's use some other color. So if we see this thing calls the reserve, and other this outer thing, if we'll see this thing, this all thing, this is called the resources. So all the reserves comes under the resources. This statement is also correct. Some accumulation classified as resources also reserve. Yes, this whole circle represent the resources. There are some accumulation that these are also considered as a reserve. Write it clearly. Resource. This thing is reserve. So this statement is also correct. So correct answer will be option number B. So that's because it's asking the incorrect statement. Let's move ahead. Typically, which of the following is true? Anybody want to answer? Let's see from the bottom. So option number D says both the renewable and the non-renewable resources are considered as a flow. No, only renewable resources are considered as a flow. Non-renewables are not considered. So that statement is false. Statement number C, both renewable and non-renewable resources are considered as stocks. No, renewables are flows and non-renewables are. So if you will see this, renewables are considered as a flows and non-renewables are considered as a stock. So this statement is also false. Option number B says non-renewable resources are classified as a flows where renewable resources are considered as stocks. This is a wrong statement. It's just opposite at whatever you have studied. Option number B, A is non-renewable resources are considered as a stock where the renewable resources are considered flows. Yes, this is right. So option number A is the correct statement. Anybody having any doubt? Okay. Yes, Shida, your answer is right. Let's move to the question number 11. Assuming that there is no other change in physical and chemical composition, the energy content of biomass reduces. So this thing we have learned in the theory classes. Assuming that there is no other change in the physical and the chemical composition. So physical and the chemical compositions are fixed. What will be the effect of the energy content of the biomass? An increase in the ash content or decrease in the moisture content? Decrease in the ash content or increase in the moisture content, or an increase in the ash content as well as the moisture content, or a decrease in the ash content as well as the moisture content. Which of the options should be the right? So here option number C is the correct. And if you will consider there is no physical and the chemical composition, the energy content of the biomass will reduce with the increase in the ash content. If the ash content will increase as well as the moisture. So as the energy content of the biomass arises from the organic carbon present in it. So energy content comes from the organic carbon. If we ash content and the moisture content will increase, that's the overall energy content of the biomass will reduce. So our requirement will be the less ash content as well as the moisture content. So that's why C option will be the correct. Anyone? Okay, let's move ahead. Which of the following comes under the thermochemical conversion route of the biomass? So we have seen just thermochemical conversion. Pyrolysis, gasification is the thermochemical route. Digestion and the fermentation are the, we have just seen, these are the biochemical extraction. These are the biochemical. Uh, I've seen some comment to the B and C. No, B and C will be the biochemical. Here we are asking the thermochemical conversion. So gasification and the pyrolysis are the thermochemical conversion. I hope this solves your problem. You get some clarity. If you still having doubt, I can still clear. Just give me a minute. Thanks. Let's move ahead. According to according to the assumption made while using Pearl curve to model the reserves of fossil fuel resources, which of the following quantities, when plotted against time, will show an increase, attains a peak, and then eventually decreases towards zero? Option is total known resources, cumulative production, annual production. So here is it's asking which of these quantities shows the curves like bell shape or bell shape curve. Bell shape curve means it's attaining its peak. It's called peak, and then it's eventually decreases to the zero. It's coming to the zero. So it's plotted against time. If you want some, correct option will be the annual production. So if you want to see the in the pearl shape, the total reserves are assumed to be the constant, and these are represented as a Q infinite. The so total cumulative production is considered as a cumulative production, and this is our total known resource. So we know QP is Q infinity upon 1 plus a to the power a into multiplied by e to the power minus bt. So here a, b and t is the time, b is the a and b are the constant. So annual production p. So here it's considered as a p. It's a is the annual production. So if you want to see calculate the p, so we can calculate first the was the ln a by b. If you want to calculate this whole thing, we can just take this thing from the a. P will be dqp upon, means if you plot these things with the respect of time. So this, if you will plot this cube, this p annual production, it will be gives you a value like bell shaped graph. So correct answer will be the annual production, and its value will be AB Q infinity e to the power minus BT. Just a minute. Okay, space. EB Q infinity e to the power minus BT divided by 1 plus e to the power minus BT of whole square. I hope you don't have any doubt. If you still have any doubt, we can just clear. Yes, answer is correct. C will be the correct option. Let's move to the question number 48. The solar radiation on allocation. Which of the statement is true from this? A combination of beam plus diffuse radiation, a constant during the sunshine hour, ranges between 1.5 kilowatt per meter square to 2 kilowatt per meter square, or it cannot be greater than 1.3 kilowatt per meter square. I've just solved this question. Correct option will be the, anybody wants to try? So answer, correct answers will be, it's a combination of the beam plus diffused. Also, so option number A is correct. Constant during the sunshine, no. It's varied throughout the day. Its ranges between, no. That option is also correct. So it cannot be greater than. We have just studied. It can't be more than 136 watt per meter square. So this statement is also correct. The correct option will be A and D. Let's move ahead. A biomass resource available as a crop residue is. First option will be, it can be calculated from incident solar radiation, cannot be computed without measurement of a tree density, variable and uncertain and cannot be estimated, obtained from the area under the crop, yield and the crop residue fiber. So Correct option will be the option number D. It's a direct answer. Biomass resource available as a crop residue is obtained from the area under the crop yield or crop residue factor. So right answer will be the option number D. I don't think it's needs further explanation. Let's see the comment. Yeah, option number D is right. Thanks. So this is all about the third type of questions. Let's move ahead with the numerical answer questions. If anyone you having any doubt, we can still get the doubts before moving to the numerical questions. No, I don't see any comment. You can also unmute yourself and we can talk. If you have any specific question. So let's move numerical answer type question. So first question is a CAGR of coal production in India from 1970 to 2022 was 4.75%. That's the annual growth. CAGR means annual growth. So annual growth C the blue column. So here it is given CAGR is given as 4.7% annually. In the 1970, coal production was 70 million. In 1970, coal production was 70 million tons. Here, million tons I'm writing as a empty. Calculate the coal production in million tons in the 2022. So 2022 we can calculate. How we can calculate? Let's see. So we know a formula production in 2022 divided by production in 1970 will be equal to the CAGR from 1970 to 2022. We know. So we don't know this to, what is the so correct will be x. So let's see x upon 70 will be equal to 1 plus 0.0475 to the power 52. As we know from 1970 to 2022 will be like 72 for 52 years. So from by solving this equation, x will be equal to 70 into 1.0.0475 to the power 52. If you will calculate it, let's see 70 into plus 0. To the power 52. Yeah, it will come around 781.82 million tons. We can also write it as 782. So correct option will be 782 million tons. Yeah, 782 million tons are correct option. See that? Let's. If you have any doubt, do you have any doubt, or we should move ahead? Let's move ahead to the question number 2. If one goes from 25 meter above the ground to 100 meter above the ground, then what factor will the wind speed increase? So we know one thing. We know there's a relation between wind speed and height. What is it? It was V2 upon V1 Z2 upon Z1 to the power alpha. So alpha is generally lies in the range of 0.1 to 0.4. Z1 is the Z is the height, V is the speed. So here it is given Z2 is given as 100 meter, Z1 is given as 25 meter. So if you want to calculate the V2 by V1, so V2 by V1 will be 100 upon 25 to the power alpha. So in that case, if we will take alpha, we can just take alpha value 0.1 and put that into the question number this equation. Then our answer Z V2 upon V1 comes out to be 1.14, and if we take alpha is equal to 0.4, that's a maximum value, then V2 upon V1 comes out to be 1.74. So that means for this range of alpha, V2 upon V1 lies from 1.14 to 1.74. Whatever the answer you will write from in this range will be the correct option. I hope this is clear. If you have any doubt, you can still clear. The way we'll move ahead. Okay, let's move ahead. Numerical answer questions. Question number 3. The Pearl curve is a popular model for studying and predicting stocks of fossil fuel reserves. It can be analytically be expressed as QP is equal to Q infinity divided by 1 plus a to the power a into e to the power minus bt, where QP is cumulative production till year T. Q infinity is the total proven reserves. A and B are the model parameters. The analytical expression for the annual, this is a derivation. So let's solve it. This will give some more clarity about this. So we know the annual production in year T is given by P to the power P is equal to B QP Q infinity minus QP divided by Q infinity, where where QP is given as Q infinity 1 plus or minus BT. So this thing is given. If we will solve further, the maximum value of P is attained when P will be ln A upon B. Therefore, QP is equal to Q infinity upon 2. If we'll put this t value, put this t value into this, then it will get this equation Q infinity will be 2. Uh, yeah. So thus P max will be B by Q infinity into Q infinity upon 2 into Q infinity minus Q infinity by 2. So here we can see these things will cancel out, and then finally we will left with B by 2 Q infinity minus Q infinity upon 2. That will 2 will be 4, and Q infinity minus, so B into Q infinity by 4. So that will be the value of, so here question asked it what the analytic expense of the manual annual maximum annual production. So the maximum annual production will be Q infinity multiplied by B by 4. So that will be the expression for maximum production. Anyone of you having any doubt, or we should move? Okay. Don't see any comments or anyone. If you want, you can unmute yourself and talk if you are facing any doubt or queries. Otherwise, we'll move. Okay, let's move. Let's move to the question number 4. What it says? It says for a country with an oil reserves of 7,500 million tons and an annual production of 500 million tons to calculate the R by P ratios. So here it is given. It is given. It's a very basic question. The reserves are given as 7,500 million tons. I think one of you are unmuted. Thanks. We consider as a R, and other thing is the annual production rate. Annual production rate is called a P. Annual production is given as 500 million tons per year, or we can write it for the year 2022. So what will be the R by P ratio? R by P ratio for the year 2000 will be 7,000 divided by 500. So correct answer will be 15 years. It's a very basic question. I hope you will get it. If you have any doubt, you can clear. Otherwise, let's move to the tutorial questions. Okay, let's move ahead. So question says, so this is an important question. This will clear most of your doubts, and uh, it can be assumed that before the start of organic life on the earth, there was no free there was no free carbon or oxygen, since they would have reacted due to the high temperature. Free oxygen in the atmosphere can be assumed to purely exist due to carbon fixation during photosynthesis, which if photosynthesis means 6 CO2 plus 6 H2O will convert our generate the our daily life energy, that is equal to 6 C6H12O6 or 6O2. Photosynthesis means where the plant makes its food. If the amount of free oxygen in the atmosphere is 10 raised to power 5 tons and the amount of fuel discovered is roughly around 10.5 into 10 raised to power 12 tons of coal equivalent, how much of the carbon reserves have yet to be discovered in the, it's asking how much of the carbon reserves yet to be discovered in percentage. Neglect the carbon contribution in the organic life. Assume the coal contains 80% of the carbon. So one thing was also given. Coal contains 80% of carbon. Hint. There's a hint given. 6 moles of oxygen are liberated for 6 moles of carbon fixation. Do you want to solve it? Want to have a try? Or I will solve it? Okay, let's move ahead. Since we assume 6 moles of oxygen are liberated per mole of carbon fixation. So around 632 tons of oxygen are liberated for fixation of 12 tons of carbon. Thus, we know that 10, whatever the things given in the question, there's one thing given that 10 raised to power 15, where it is. Yeah, atmosphere. The free oxygen available in the atmosphere is 10 raised to power 15. So 10 raised to power 15 tons of free oxygen that would have around 10 raised to power 15. So that will, let's calculate. So based on that equation that is given, we'll calculate 375 into 10 raised to power 12 tons of carbon fixation. So if what's the other thing? If only 10.5 into 10 raised to power 12 tons of coal equivalent have been discovered, assuming, what's the assumption? 80% of the carbon. This is our assumption. We we can assume. So based on that assumption, we can assume that amount of carbon discovered in coal equivalent is 8.4. So if you will multiply 10.5 with 80%, that will come around, so at 80%, 0.80 into 10 raised to power 10.5 into 10 raised to power 12. That comes out to be 8.4 into 10 raised to power 12, which is 2.24% of the total carbon that is yet to be discovered. So we know 100 is the total percentage. Where we have not 2.24%. So the remaining will be 97.76% of the carbon reserves. Sorry, carbon reserves that are yet to be discovered. The right answer will be 97.76. So this is the thing I've solved. If you have any problem, still clear. Otherwise, we'll move ahead. Just wait for 1 minute. Okay, let's move. Yeah. Question number 2. For a country with an oil reserves, this is a big question. It will take some time. For a country with an oil reserves of 5,000 million tons and annual production capacity of 200 million tons in 2022, the annual production of 150, how many years it will the oil will last? We have just solved this question, this type of question, how many years it will last. So there are some other information that is given. That is in the year 2014, the annual production rate was 150 million tons per year. So let's see. So this one also. In year 2014, the annual production was 150 million tons. This is increased to 200 million tons in 2019. So this translates. So this, so we know initially in the 2014, the annual consumption was the annual production rate was 150. In the year 2000, sorry, in the year 2019, it's increased to 200 million ton. So this translates. So from that we can calculate the CAGR. Yes. So the CAGR growth, this translates to the compound CAGR. CAGR will be the compound annual growth rate. CAGR will be final upon initial 1 by n minus 1. In this case, n will be from the year 2014 to 2019. So that will be around 5 years. And the final and initial rate was given. So CAGR will be 200 divided by 150 to the power 1 by 5 minus 1. So in that case, CAGR comes out to be 0.059, comes out to be around 5.9%. That means it says the oil production grows at 5.9% annually. So mathematically, so we know initially mathematically, so we have to calculate how many years this will last. Based on that, we have calculated the CAGR. So uh, let's move further. Anyone of having any doubt till now? Okay. So mathematically, R is equal to the total proven reserves considering at considering production at same CAGR. So R will be sum of P and P1 plus G plus dash till the year n, 1 plus G to the power n plus 1. So we can write it as a 1 plus G as a but P plus G, P 1 plus G square till P1 plus G to the power n plus 1. So we had just multiplied here, just multiplied with 1 plus g on the both side in the equation number 1. So we will get equation number 2. Let's see. So if you will now subtracting equation 1 minus 2, or will 1 plus g will be p 1 plus g. That will comes out to be, if we'll just write it, 1 plus g minus r, that will be equal to 1 plus g and plus 1 minus p. So if you will multiply subtract equation number 2 from the 1, we will just, all the things will be cancelled out, we will remain only these things. So if we will solve this equation, solve equation number, let's give it equation number 3, solve equation 3, we will get rg will be equal to p 1 plus g to the power n plus 1 minus p, which implies, so if you will just shift this equation, which implies r by p will be 1 plus g to the power n plus 1 minus 1 to the power g. We just changing this equation, taking p as a common from these two things. So finally, this equation which looks like this thing. Let's move ahead. So finally, so we have just calculated. So just replace, placing value of r by p to be 25 years and g to be 0.059. We get 25 equal to 1.059 to the power n plus 1 minus 1, 0.059. So here we are g we have just calculated as a 0.059. That's why we are putting this value CAGR, and 25 the production rate that we are getting. So let's move. If you will solve this equation, 25 into 0.059 plus 1 will be 1.059 to the power n plus 1. So if we will take natural log on both sides, we'll get ln. If you will solve these things, so if you will solve these things, we will get 2.475. So ln 2.475 will be equal to n plus 1 ln 1.059. In that way, n will be equal to ln 2.475 divided by ln 1.05, sorry, 0.059. That way, and we can calculate it 14.8. Hence, we can say the resources will now last for 15 years. We can just write it as. So we have started with this question. Let's just revise. We have just started with question how many years this will last. So initially we have calculated from the year 24 how many years are there? There are 5 years. So data for 2014 and 2019 was given. So we have first calculated the CAGR. CAGR comes out to be around 5.9% annually. So we can say that annual production rate goes to a 5.9%. Then we have just write a mathematical equation for resources, total proven resources. We have just multiplied this equation both sides 1 plus G. Just rewrite it. On the both sides. Then we have found this equation 1 and equation 2. We have just subtracted equation 1 minus equation 2. Equation 2. Then we get the equation number 3. And if you solve this equation number 3, we will get R by P ratio. So as we get the R by P ratio, we got the value. We know the R by P ratio is 25, and we have just calculated the G value 0.059. So we have to calculate the number of years, that is n. So if you will take the log from the on the both sides, we have just solved this equation and we get the value of n is equal to 15 years. So it's a typical question. We have just you can just you can be asked single parts or a full question in the final exams also, and the quizzes you will find some of these type of questions. So if you have any doubt, I'll wait for 2 minutes before moving ahead. Anyone of you having any doubt? Otherwise I'll move ahead. One thing that you are wondering that how I've taken this value as a 25. So 25 value is coming directly from, we have given oil reserves of 5,000. So 5,000 divided by annual production rate of 200, that comes out to be 25. So that is the R by P ratio here, reserve by production. So this sums up the whole question. I don't know if it's clear now. Anyone having any doubt? I don't see anyone raising any questions on the chat box also. You can leave.
Okay, sir.
Okay, thanks.